So AC circuit containing only capacitor, or it is also known as a capacitive circuit. Okay. So this is the circuit diagram. This is the capacitor. That is, we will draw the capacitor like two plates. That is two parallel plates like this. And one plate will be positive and the other plate will be negatively charged. That is capacitor. Okay, so this is the capacitor, and one plate is positive and the other one is negative. Parallel plates. So parallel plate capacitor. Different types of capacitors are there. Okay, and we are applying the potential like the same steps. Okay, we are applying an alternating potential, that is V equal to V0 sin omega t. We can take that as our equation 1. Okay, and the capacitor here, if V is the potential applied, that is external potential applied, then there will be some charges stored in that, and that stored charge Q is the charge stored in the capacitor, and V is the applied potential, and C is the capacitance of the capacitor. These three are related like that is the charge, this is the relation comes, that is the charge stored in the capacitor is proportional to the applied potential. That is the relation. How much potential we are applying, accordingly the charge, amount of charge gets stored in the capacitor. So Q proportional to V, and that proportionality we are changing by adding the constant, and this constant is the capacitance. Okay, that is the property of the capacitor C. So we can use this relation here, that is Q is equal to CB. Okay, Q is equal to CB, where Q is the total charge stored in the capacitor, C is the capacitance of the capacitor, and V is the applied potential. Okay, here the applied potential is V equal to V0 sin omega t, alternating potential. From this we can write, we know V, so we can rewrite the equation in terms of that, that is V is equal to Q by C. V equal to Q by C. And what is our aim? We have to find out what is the current, isn't it? Then only we can find out what is the relationship between the voltage and current. So to find out the current, we know that current I is equal to, we have charge here, like voltage we know, capacitance we know, and charge we can find out from this equation. If you know charge, we can find out current, that is we know the relation current I is equal to dq by dt. If Q is the small amount of charge and it is increasing with the time t, so I is equal to dq by dt. It's the rate of change of charge. So we can use this relation to find out the current flows through this circuit. Okay. So what can you write here? From this we can write, initially we are considering only small charge Q. So I am writing Q is equal to Vc. Okay, small charge here. For a small interval of time t, the amount of charge flows stored in the capacitor Q is equal to Vc, or it is equal to V0 sin omega t into C. So how can you find out I, current? That is current I is equal to, we have current I is equal to dq by dt. That is d by dt of, substitute for Q. What is Q? Q is equal to V0 sin omega t into C. Isn't it? And in this equation, V0 and C, it is constant. So we can take V0 and C outside. And what comes next? D by dt of sin omega t. Then d by dt of sin omega t. What is d by dt of sin theta? It is cos theta. But here it comes V0C cos omega t, and here omega t comes. Omega is related with the variable time. So that also we have to differentiate. So we will get omega. So I am writing all the constants together. V0 C omega cos omega t. And this, we read the equation in some modification, and we have to write it in terms of sign. Then only we can compare it. So there is little modification in the equation, that is V0, and this C omega I am writing it as 1 by C omega. Okay, C omega, we can write it as 1 by C omega cos omega t. So, what is the current? We got the current as V0 divided by 1 by C omega cos omega t. And from this, we can write it as I equal to V0 by R. In place of R, what is it? 1 by C omega. So, let comparing with Ohm's law. So, instead of 1 by C omega, I am writing it as V0 by XC, and cos omega t we can write in terms of sine, that is sine omega t plus pi by 2. Sin 90 plus theta is cos theta. So instead of writing 90 plus theta, I am writing theta plus 90 because we know that this is the phase angle. So rewriting in this. And what is this XC? XC is equal to 1 by C omega. So it comes in the position of opposition. So it is the opposition offered by the capacitor to the flow of current. And that opposition, it is known as capacitive reactance. It is known as capacitive reactance, and in the other case inductor, it is known as inductive reactance. Resistance and reactance, that is the classification. Resistance, it is the opposition offered by the resistor. Reactance is the opposition offered by inductor and capacitor to the flow of AC. If it is inductor, we are calling it as inductive reactance, and capacitor, it is known as capacitive reactance, and here also the unit is ohm. Okay, position on, so the unit is ohm. Inductive reactance. So you can see that the inductive reactance, capacitive reactance is inversely proportional to, inversely related to what? Capacitance and angular frequency. The other case, what was it? XL is equal to L omega. It is directly proportional, and here it is inversely proportional. That is, capacitor offers very less, that is negligibly small opposition to the flow of AC. That is, it allows AC to flow, capacitor. Okay, it is inversely proportional. And inductor, what is it? It is directly proportional. So here the opposition is very high. That is, it is offering an infinite opposition to the flow of AC, and it is offering negligible resistance to the flow of AC. So that is the difference between the capacitor and inductor with the flow of AC. Okay, so come to the equation. We can take this as equation 2. So comparing equation 1 and 2. What is it? 1, V equal to V0 sin omega t. And equation 2, instead of this, I am writing it as I0. V0 by R, it is I0. So it is I0 sin omega t plus pi by 2. Okay, sin omega t plus pi by 2. So comparing equation 1 and 2, it is very clear that it is not like the case of resistor. Resistor we got V equal to V0 sin omega t and I equal to I0 sin omega t. And in inductor, there is a difference. V equal to V0 sin omega t and I equal to I0 sin omega t minus pi by 2. Here you are getting it as plus pi by 2. Okay. From what is it? We can say that, we can generalize that in the case of an inductor and capacitor. In the case of an inductor and capacitor, there is a phase difference between voltage and current. Okay, and what is the phase difference? Phase difference is same in both the cases. How much it is? Pi by 2. And what is the difference? In the inductor, it is minus, isn't it? It is minus pi by 2, and here it comes plus pi by 2. So how can we say? In the case of a purely capacitive circuit, which leads? Who will go first? Current goes first. Like current leads voltage by an angle of pi by 2. Okay, current leads voltage by an angle of pi by 2. Understood? So we have to represent that graphically and with a phasor diagram. Okay, let us go for the graphical representation and a phasor diagram. So graphical representation, x-axis and a y-axis. This is omega t, and y-axis we can mark this EMF voltage and current V and I along y-axis. And what is the equation? V equal to V0 sin omega t, and I equal to I0 sin omega t plus pi by 2. Okay, I0 sin omega t plus pi by 2. So V0 we know, many times you have plotted the graph. So here we can plot it like this. Here it comes 0, 90, 180, 270 and 360, or it is 0, pi by 2, pi, 3 pi by 2 and 2 pi. Okay, that is in terms of pi and in terms of the numeral value. That is the difference. So pi by 2, pi, 3 pi by 2 and 2 pi. So we can represent sin 0, it is 0, sin 90, it will be maximum, it comes here V0, and 180 again 0, 270 it comes minus value minus V0, and 360 again 0. So joining the point, you will get a curve like this. Okay, that is the voltage. In a current, let us see current, how is it? What is that? Initial case, omega t is equal to 0. So what is I? I equal to I0 sin 0 plus pi by 2. Isn't it? Sin 0 plus pi by 2. Sin 0 plus pi by 2 is sin pi by 2. It is 1. So it is I0. When omega t is 0, that is the first angle is 0, we are having a maximum current, that is I0. At that time, what is the voltage? Voltage is 0. Okay. The next case, omega t plus, equal to what? 90. So that is equal to pi by 2. So what is I? I equal to I0 sin pi by 2 plus pi by 2. Pi by 2 plus pi by 2 is 180. Sin 180 is 0. So what comes? I equal to 0. It is here. That point comes here. Then next is omega t is equal to 180. That is pi. Isn't it? So I equal to I0 sin pi plus pi by 2. That is 3 pi by 2. There. Sin 3 pi by 2 or sin 270. 3 sin 270 is minus 1. So it is minus I0. So it comes here. Maximum. Minus I0 will be here. The next is what? Omega t is equal to 270 is equal to 3 pi by 2. That is I equal to I0 sin 3 pi by 2 plus pi by 2. How much it is? 4 pi by 2. It is 2 pi. Sin 360. It comes 0. So where is the point? This is the point. And the last one is sin 360. So sin 360 comes, what is it? It is equal to, again, sin 360 plus 1. 360, that is 2 pi plus pi by 2. It is 5 pi by 2. So what is the value? It comes 1. Isn't it? So it comes, what is it? I equal to I0. So where is the point? This is the point. So joining all the points, how is the curve? This is the curve. So this is for applied potential and this is for the current. So look at the graph. This is very clear from the graph. It is very clear from the graph. Voltage 0, but current is not 0. There is a current across the capacitor. And voltage becomes maximum. What happened to the current? The current becomes 0. That is, the capacitor is fully charged at that time. And here again, here 0, but the current flows in the opposite direction. So it comes minus I0. Then your voltage becomes negative, but there is a negative maximum, but there is no current. And here the potential 0, there is maximum current. Compare all the graph. Okay, resistor, capacitor and inductor. Comparing all the three graphs, we can very easily identify the difference. What is it? Here the current leads. Capacitive cell, do you remember like this? Capacitor under C. The That's C for current. Okay. So which comes first? Current leads. Current leads voltage by an angle of how much? By an angle of 90 degree. In both cases, the phase difference is 90. In inductor and capacitor, the phase difference is 90, but the difference is in inductor, voltage is going first, and in capacitor, current is going first. Okay. And phasor diagram. How the phasor diagram will be? That is the vector representation of voltage and current. Right? So always you keep a voltage in the first quadrant. Okay. X dash, Y and Y dash. So we are keeping voltage. This is the voltage vector V, and here where will be I? Here the I will be here, isn't it? It is moving in the anti-clockwise direction. So I will be here, and what is the phase angle between them? It is pi by 2. Okay, so yeah, current goes, then behind the current by an angle of 90 degree, voltage comes. This is known as the phasor diagram. Okay, so capacitive circuit is the relation, and the graphical relationship between representation between the relation between what is that XC and omega. We said it is inversely proportional, so the graph will be like this. XL and omega, it will be a straight line. Omega and XL, it will be a straight line, directly proportional. That graphical relationship also. Okay, so we can summarize that. What are the things we studied? So listen, here a brief explanation of these three things: resistive circuit, inductive circuit and capacitive circuit. And in both the case, all the three cases, the applied potential is V equal to V0 sin omega t. And here the current, first is current is I equal to I0 sin omega t, and here I is equal to I0 sin omega t minus pi by 2, and I equal to I0 sin omega t plus pi by 2. And here the phase difference is 0. We can write voltage and current. Voltage and current are in phase. Current in phase. And here there is a phase difference of pi by 2. Voltage leads current. Here there is a phase difference of pi by 2. Current leads voltage. And the opposition is resistance, or unit is ohm. And here it is inductive reactance XL, L omega ohm. Capacitive reactance XC, 1 by C omega ohm. Graphical representation. Voltage and current are in same phase. Here voltage leads current. Okay, that magnitude will be less. While drawing, you have to be very careful. And here current leads voltage. Current here 0, current is more. At zeros, current is more and voltage is less. Okay, current leads voltage. And that's anyway the graph will be given. So you have to identify. The small graph will be current and the bigger graph will be for voltage. In the problem, it is not necessary that the graph have to be given like this. That is the initial case. It is starting like this. Okay, they can start from this section onwards or this section onwards. At any point they can start the graph. But you have to, from the graph, you have to identify which is first. Small one is, that is the thing. Small graph will be for current and bigger graph will be for voltage. Okay, from where, which is starting from where. From that you can identify which circuit it is. That will be the question. Graph will be given and you have to find out which circuit it is. Whether it is inductive circuit or capacitive circuit. And this is the phasor diagram. Same phase. Voltage leads by an angle of pi by 2 and here the current leads by an angle of pi by 2. It is rotating in the anti-clockwise direction. And this is only for the two inductive and capacitive circuit. Relation between reactance and omega. It's a direct relation and it is inversely proportional. Okay. So that is these are the things we studied. Next we are moving to the combination of this. Okay. That is combination of what is this resistor, capacitor and inductor. Not necessary that only one component is connected in the circuit. The circuit, it consists of all the components. It may connected in series, or it may connected in parallel, or it is in the mixed combination. Many possibilities are there, and they are we are doing like that also. But now we have to study the next combination. There is only one combination we have to study, that is here the resistor, capacitor, in an inductor, if they are connected in series, that is one after the other series, if they are connected, what is the relationship between the voltage and current? Well, there is no this mathematical derivation. We are solving that on the basis of the phasor diagram. Just on the basis of the phasor diagram, we are solving, we are finding out what is the current and voltage, and what is the phase relationship between voltage and current, and what is the opposition offered by the circuit to the flow of current and voltage in that circuit. Which circuit? A circuit containing only the series combination of inductor, capacitor and resistor. We are calling it as the LCR circuit. Okay. So you have to study this table carefully. What are the things we discussed? Everything is there, and that derivation also, in between that derivation is coming, that you have to study separately. Okay. 1 mark questions, everything is there. So let us see what is the series combination, and what are the things related with that. Okay, that is our next topic.